Alright, so we are now going to talk about two particular types of circuits. And as well as that, we're going to talk about what voltage is and what current is. Okay, so series and parallel circuits. That's the two we're going to talk about today. Now, basically, all circuits are either series or parallel. Now, if we're being honest, most circuits that are used in modern homes, etc., are actually a combination of both. Now, series circuits are like this one here, right? So if we label this one with an A and this one here with a B, the series circuit is A and the parallel circuit is B. Now if we have a look, there is one continual path for electrons to flow around. Parallel circuits can have two or more alternative paths. So this one, that it can go around and it hit here and it has a choice. It doesn't really have a choice. They go half this way, half that way. So there are separate ways that the electrons can go. Now, we can look at this using a Venn diagram. That's what this sort of circle's called here. So if we write everything that's different about a parallel circuit, so if we write everything that's just parallel circuits in this part of the circle, everything that's just series circuits over here, and the similarities. Now, they're actually pretty different. Like the main similarity is that they convert the energy in the load to a different type of energy. But the series circuit has one pathway. The current is the same anywhere in the circuit. Okay, so the current here or here is the same. In this one, the current splits, and it splits pretty much halfway. So if the current here is at 3 amps, at here it's going to be 1.5, and here it's going to be 1.5. And that's cool. Okay, the voltage across each pathway equals supply voltage. So if we go in blue for voltage, okay, well actually while we're at it, so this one will get 3 amps, and this one will get 3 amps. And so that's what that means. Now if we go to a blue here just for the sake of keeping it all separate, so that's amps. Now if we want to voltage, you can see here the voltage across each pathway equals supply voltage. So if we're at something here which is 6 volts, that means this one will get 6 volts and this one will get 6 volts. That's very interesting. We put a little V there, so that makes sense. If you're going to put numbers on something, you should label it, which means this one here should have an A. But whatevs, you get it. And if this one has 6 volts at the power supply, what we see here is the voltage is shared in ratio to resistance. So if these two globes are the same, what that actually means is, so you've got 6 volts here, 6 volts here. This one will have 3 volts, and this one will have 3 volts. Now, have a think about what you think that might mean for how bright those lights glow. Now, resistance adds up. Total resistance is less than the least resistance. You don't need to worry about that actually, so don't write that down. Don't write that down. One bulb fuses, the circuit's incomplete. So if this bulb here stops working, the total circuit will stop working. If this bulb stops working, then the rest of the circuit will still work. So think about how that might affect, say, your house. If one part goes, then the rest of it will go. But if your house is set up in parallel, you can have different little circuits going off, and the rest of the house will maintain electricity. All right. So what is current? Basically, current is the flow of electricity. We use it to measure the number of charged particles passing a point every second. As far as you guys are concerned, we measure it using an ammeter. That's this symbol here. And it's measured in amperes. That's the unit. Or you can just call it amps. And we connect it in series. So it actually measures the particles going through. Voltage, on the other hand, is measured in parallel. So what you're actually measuring is you're measuring the amount of voltage used up by that piece of equipment there, that resistor. So voltage is the energy pushing the electrons on. It's the energy causing the electrons to move around the circuit. It's measured using a voltmeter, this piece of gear here, and it's connected in parallel. So it measures the energy used up by the load just here. Alright, so we'll play with those in class for the next few lessons, and that should be lots of fun.